All right, this is going to be a practice show. Um, uh, it's going to be a practice. All right, so you're free to record, um, post. Not everything here, all the pictures here are cited. So, but you can definitely record this if you want it for yourself. I don't. I'm not going to come after you. This is going to be the philosophy of Antoine Lavoisier, father of physical chemistry. This is going to be referenced from this book. It's called Elements of Chemistry in English, or Triet Elementary de Chimie. I hope that's how you say it in French. I don't really know. If you really want to, if you would like a copy, you could always access this. It's going to be the preface of this. I need a better intro. This is going to be the preface to this book, which is considered one of the world's first chemistry books. On the far right, you could see that it's the original French copy. The one in the middle is the first English translation in 1790, and the one on the left is my copy edit of the 1790 copy. And I just love this preface so much. This is going to be a nice stroll in the park, basically. Um, I'm going to take my time and we're going to enjoy this roll. But I just want you to understand, like, we're just hiking through the woods, basically, and just enjoying the philosophy of a great scientist. So we're going to do the first three paragraphs verbatim. We're going to go over the analysis of Lavoisier's seal, a philosophy of science and its language. It's going to be the third paragraph primarily. You're going to notice uh, I'll have this paragraph 3 thing up, and that'll tell you which paragraph it's in for the preface. Then we'll go over the old paragraphs 13 and 15, as well as a brief biography of Mr. Lavoisier. If you didn't know what Mr. was short for, that's the Old English Mr. Meser. So I thought it was fun. We'll get back to the preface and hopefully make it to the conclusion. Spare no prop. We might get to this, we might not, but I hope we do. Let's begin. When I began the following work, my only object was to extend and explain more fully the memoir which I read at the public meeting of the Academy of Sciences in the month of April 1787, the necessity of reforming and completing the nomenclature of chemistry. While engaged in this employment, I perceived better than I had ever done before the justice of the following maxims of the Abbé de Condillac, which I think is the priest of Condillac, in his system of logic and some of his other works. We think only through the medium of words. Languages are true analytical methods. Algebra, which is adopted to its purpose in every species of expression, in the most simple, most exact, and best manner possible, is at the same time a language and an analytical method. The art of reasoning is nothing more than a language well arranged. Thus, while I thought myself employed only in forming a nomenclature, and while I proposed myself nothing more than to improve the chemical language, my work transformed itself in my work transformed itself by degrees, without me being able to prevent it, into a treatise upon the elements of chemistry. Just the impossibility of separating the nomenclature of a science from the science itself is owing to this, that every branch of physical science must consist of three things: a series of facts which are the objects of the science, the ideas which represent these facts, and the words by which these ideas are expressed. Like three impressions of the same seal, the word ought to produce the idea, and the idea to be a picture of the fact. And as ideas are preserved and communicated by means of words, it necessarily follows that we cannot improve the language of any science without at the same time improving the science itself. Neither can we, on the other hand, improve a science without improving the language or nomenclature which belongs to it. However certain the facts of any science may be, and however just the ideas we may have formed of these facts, we can only communicate false impressions to others, while we want words by which these may be properly expressed. And that's going to be the seal. That's Lavoisier's philosophy of language. We're going to go over it more. This is what treatises. I didn't know this before, in case you didn't know it. Just, I thought this would be fun to include. So, a quick review: the only object was the necessity of reforming and completing the nomenclature of chemistry. And from his quote, we think only through the medium of words. Languages are true analytical methods. The art of reasoning is nothing more than a language well arranged. So while I proposed to myself nothing more than to improve the chemical language, my work transformed itself by degrees without my being able to prevent it into a work upon the elements of chemistry. Basically saying, like, by improving his language, he improved his reasoning on the science and just became, here's what it is. And so every physical science must consist of three things: series of facts, which are the objects of science. Here I have these interesting formations on rocks. How did these get here? The ideas, which represent the facts, maybe from water, maybe from wind, and the words by which these ideas are expressed. So this is like our data collection, our analysis, and we finally come up with the language we have for this kind of process. Um, like three impressions of the same seal, the word ought to produce the idea, and the idea to be a picture of the fact. So my first impression of this was literally just pressing the seal down 3 times because it'd be fragile, and like any kind of twist or deviation would like change the design of the seal. My second impression was that you're just doing across 3 letters or 3 different documents. It's the same design. And my third impression, uh, I should change that. My third impression was the word is the wax seal. The translation of metal stamp. The word is the wax, like the picture of the thing. Like the wax has the picture on it now, but where did that picture come from? Those are the words. And that came from the idea, which is the stamp steel, which is actually a negative of the original. So it's like, it's still not the original. And the original is the fact, which is the original cast that was used to make the stamp, which is imprinted on the wax. Like what you see on the wax is what would have been forged. And so I'm not really sure which one he chose. Um, I don't work with wax a lot. I think one of the last two are probably most correct. I don't know. It could be the first one, but these are my impressions. Um, and I love this part. As ideas are preserved and communicated by means of words, it necessarily follows that we cannot improve the language of any science without at the same time improving the science itself. There's a deep relationship between the words and science. So how we use our words, it's important. And so neither can we, on the other hand, improve a science without improving the language and nomenclature which belongs to it. And I thought this was like good, because if we want to improve a science, this gives us a roadmap. We need to improve the language, how we talk about it, how we write about it, and how we communicate it with other people so that we could better understand. Because nothing's worse than when someone's trying to tell you something and you're just, yep, 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 but it's not really connecting. It's like science is supposed to communicate ideas and or languages, and so we got to be diligent about that. However certain of any facts, any science, the certain of the facts any science may be, and however just the ideas we may have formed of these facts, we only communicate false impressions to others, while we want words by which these may be properly expressed. And this just made me think of things like Plato's cave, Plato's naked woman behind the veil. You started getting to like Descartes and like his reductionism, which gets you into like are we in the matrix? Like what is really real? And, which is just extension of brain in the vat, extension of the demon controlling the senses. But I don't think Lavoisier's philosophy gets that much into anti-realism. I think it touches closer to the Platoistic. It's just beyond our touch. Basically, like the woman behind the veil or the cave, the light beyond the caves. Um, just false words leading you further down, or better words leading you closer up. Um, because these are a series of facts. Like that's one of the things he does say. There are three things. And one is the series of facts which contains the science. So I need to re-highlight that. So the world is the same before or after we discover these facts or have layers. Basically, there's reality, and our words are a layer on top of the facts itself. And so just so we can read it again, I broke it up again so it's a little bit simpler. But essentially, what this is saying is this is just a game of telephone. And I found this to be super freeing because just personally, can't always express myself the best way I want to, and how I want to. And what this is saying is it doesn't even matter if it's an objective science. You can't express it the way you want to. So there's no chance that you could express your feelings the way you want to. And it's freeing in the sense that you don't have to struggle against that attempt for perfection. You could just try your best, and that seems to be good enough. And so that's part one. We'll go a little bit more into part two, or into this old ways and a little biography. We'll see if we have time. I think I have just about 10, maybe 15 more minutes, so we have questions. So, what is an element in this book, Elements of Chemistry? So it will no doubt be a matter of surprise that in a treatise upon the elements of chemistry, there should be no chapter on the constituent and elementary parts of matter. But I shall take occasion in this place to remark that the fondness for reducing all bodies in nature to 3 or 4 elements, so this is the old ways, proceeds from the prejudice which has descended to us from the Greek philosophers. The notion of 4 elements, which by the variety of their proportions compose all the known substances of nature, is a mere hypothesis, assumed long before the first principles of experimental philosophy or of chemistry had any existence. In those days, without proposing facts, they framed systems, while we, who have collected facts, seem determined to reject them when they do not agree with our prejudices. The authority of these fathers of human philosophy still carry great weight, and there is reason to fear it will even bear hard upon generations yet to come. It is very remarkable that, notwithstanding the number of philosophical chemists who have supported the doctrine of the 4 elements, that there is not one who has been led by the evidence of fact to admit a greater number of elements into their theory. The first chemist who wrote after the revival of letters considered sulfur and salt as elementary substances entering into the composition of a great number of substances. Hence, instead of 4, they admitted the existence of 6 elements. Becher assumes the existence of 3 kinds of earth, from the combination of which, in different proportions, he supposed all the varieties of metallic substances to be produced. Stahl gave a new modification of this system, and succeeding chemists have taken the liberty to make or to imagine changes and additions of a similar nature. All these chemists were carried along by the influence of the geniuses of the age in which they lived, which contented itself with assertions without proofs, or at least often admitted as proofs the slightest degree of probability, unsupported by that strict, rigorous analysis required by modern philosophy. All that can be said upon the number and nature of elements, in my opinion, confined to discussions entirely of a metaphysical nature. The subject only furnishes us with indefinite problems which may be solved in 1,000 different ways, none of which are in probability consistent with nature. I shall therefore only add upon this subject that if by the term elements we mean to express those simple and indivisible atoms which matter is composed. Oh yeah, that should have been in there faster. Okay. I it is extremely probable we know nothing at all about them. But if we apply the term elements or principles of bodies to express our idea of the last point of analysis which is capable of reaching, we must admit as elements all the substances into which we are capable by any means to reduce bodies by decomposition. Not that we are entitled to affirm that these substances we consider as simple may not be compounded of 2 or even a greater number of principles. But since these principles cannot be separated, or rather since we have not hitherto discovered the means of separating them, they act with regard to us as simple substances, and we ought to never suppose them to be compounded until experiment and observation has proved them to be so. And this would remain true until 1897, with J.J. Thomson discovering the electron with his cathode rays, giving us the plum pudding model, developing into the Bohr model, developing into Schrodinger-Heisenberg models. Or, however, on the death of Lavoisier, he was executed by guillotine during the French Revolution. I have this quote from Wikipedia. On the 24th of November, 1793, the arrest of all the former tax farmers were ordered. Lavoisier and the other farmers general faced 9 accusations of and other tax collectors, faced 9 accusations of defrauding the state money owed to it and adding water to tobacco before selling it. Lavoisier drafted their defense. The court, however, was inclined to believe that by condemning them and seizing the goods they had, the general farmers, they would receive huge sums for the state. According to popular legend, the appeal to spare his life in order that he could continue his experiments was cut short by the judge. The republic needs neither scholars or chemists. The course of justice cannot be delayed. Lavoisier was convicted and guillotined on the 8th of May, 1794 in Paris, at the age of 50, along with 27 co-defendants. The judge, Coffin Hall, himself would be executed less than 3 months later in the wake of the Thurman reaction. And it's said that he blinked to demonstrate consciousness after. Just to reiterate, like how much of a scientist he was. But this is an urban legend, and it's not technically canon. So it was nice that he was exonerated. And a year and a half after exoneration, Lavoisier was completely exonerated by the French government. During the White Terror, his belongings were delivered to his widow. A brief note was included, reading, "To the widow of Lavoisier, who was falsely convicted." Through his lifetimes, a significant portion of his fortune went towards benefiting the public good. Lavoisier was a humanitarian. He cared deeply about the people in his country and often concerned himself with improving the livelihood of the population by agriculture, industry, and the sciences. Oh, yeah. His first contribution in 1765, he submitted an essay on improving the urban street lighting. 3 years later, he focused on designing an aqueduct to bring the Southern River into Paris, so that they could have clean drinking water. But the construction never commenced, so he turned his focus into purifying the water from the Seine. And this interest in Lavoisier in chemistry of water and public sanitation. Yeah. Additionally, he was interested in air quality. 1772, performed studies on how to reconstruct the a hospital after it had been damaged by a fire, so they could have proper ventilation and clean air throughout. And prisons were known to be pretty rough in Paris, inhumane. And so he actually took part of an investigation in 1780 on the hygiene of prisoners and made improvements to living conditions to help them out. But these suggestions were largely ignored. It was difficult for scientists at the time to secure public funding, and additionally, not very financially profitable for the average scientist. So Lavoisier used his wealth to open a very expensive and sophisticated laboratory in France so that scientists can study without the barriers of securing funding for their research. Once a part of the French Academy of Sciences in 1768, Lavoisier also held his own competitions to push the direction of research towards bettering the public and his own work. He pushed for public education of the sciences. He founded 2 organizations which were created to serve as educational tools for the public. The museum is still open, and the Lycée, which was his public school, is now the name of pre-college studies in France. Lavoisier had a vision of public education having roots in scientific sociability and philanthropy. Okay. Lavoisier gained a vast majority of his income by buying stock in the Farm General at 26, which allowed him to work on science full time, live comfortably, and allowed him to contribute financially to better the community, basically investing in taxes. It would also contribute to his execution during the Reign of Terror, unfortunately. He studied to improve many things, including tobacco, how to make it taste better. He tried to figure out how to make better use of agricultural land that was full of blight. And he found out that even if we were to repurpose it, there was too much taxes. So he was actually an advocate for lower taxes on farmers. And he also invested in studying gunpowder as well. His other works include that I've been interested in are the memoirs on combustion, memoirs on heat, and methods of chemical nomenclature. I haven't read all of these. I don't speak French or read French. I've read the memoirs on heat, a translated version. It's brilliant. Talks about Lavoisierian physics and Lavoisierian thermodynamics. That introduces the world's first calorimeter. It was co-authored by Pierre Simon de Laplace. So it's not just Lavoisierian, but it also is Laplacian. And this is actually how you spell his name, de Laplace. I know we get it wrong today, but it's okay. His conceptualization on measuring heat, temperature, is an average of the room, and it takes a while for it to adjust to a reaction. So you don't really get to understand the heat transfer from a chemical reaction because it takes too long to understand. And it's interesting reading this because they are still getting used to thermodynamic or thermometric measurement, I guess would be the case, because it's still relatively recent for Lavoisier's time. You could talk about how he marks and measures, comes up with his own 80-degree, I think, measurement system. And so on, I guess I should skip all this. It goes, the elements of chemistry was a combined 23 heat. Yeah, I should have, then I should go to here on heat. It was in 1783 that he talked about the memoirs on heat. It's something that we still use today, as a theory of respiration is combustion, ironically, to his philosophy. But in his actual work on where he comes up with the calorie, he's intentionally avoided any disquisitions relative to phenomena of respiration, blood, how your body makes blood, or how it maintains body heat. In this book, he imposed a law on himself to never advance beyond what is known, therefore, any conclusion that is not an immediate consequence necessary following from observation. But we still cite today that Lavoisier proved that this respiration is combustion in the mitochondria. That's from the Britannica, even though this has clearly obvious mistakes. He hoped to get there one day in the future, but unfortunately, he was beheaded. Um, So our caloremic standard we still use today, are based off of these. I think it was my professor always wondered why we used 14.5 to 15.5, and I think after this research, I think I have an answer. The room temperature. That was a high school chemistry teacher. Um, okay, I think so. I should maybe go over theory, heat, or repulsive force, whatever that may be, so we can measure in abstract mathematical manner. I think I should talk about the calorie. Okay, so I should go calorie, ice melt as a standard, exonerated to, and then everything is chemical. Okay. In this book, Elements of Chemistry will be the foothold. I need a better title. Will be the foothold for the periodic table, physics, nutrition, chemistry. That because everything is chemistry. It's broken down into three parts. The first part is basically the foundation of theory, experiments, and the elements, that came from the experiments. And part two kind of organizes this more into tables of elements and like how different nomenclature, how they're going to use them. And this is the description of the instruments and the operations of chemistry, of the things that he used. So all three of these parts aren't very separate; they're very much integrated, to themselves. Um, and here are some of the chapters just to go over, so you can kind of get some excitement. Chemistry of the atmosphere, first ever chemistry of water, first ever chemistry of vegetables and animals. This is where we discovered things like, if we're studying this, obviously we're going to start discovering things like nitrogen, oxygen, of course, and hydrogen, especially when we're studying that water. Studying animals and everything, we get that carbon, and then these later are going to become the molecules that we know as like proteins, carbohydrates, lipids, um, and there's more, even more than that. There's the chemistry of metal, chemistry of fermentation. It's a beautiful book on the origins of chemistry. Um, these are some of the plates that are included from the figures. Like on the top right, you can see in the center, it's figure 5. It might be hard to read, but it's the one with the circle. That was for cutting flasks. On the top left in the center, those are furnaces for like warming bottles and bringing things to temperature, a grated furnace. Um, these were tools for the analysis of atmosphere and gases, and this is all included and also in the Gutenberg version as well. Um, Lavoisier's original gasometer, the tool that might furnish a uniform continuous stream of oxygen, experiments of fusion, um, and tools for the analysis of fermentation as well. It's just this whole complicated. I don't ask me what everything in here does, but he describes some of it in the book and what these tools are used for. And this is about furnaces, like different designs on furnaces. It's beautiful. And so we're at the final part. We got 5 minutes left. It's supposed to be for questions, and so unfortunately, I don't have time for this. But he did talk about our language is spoken by our masters, and they distinguish their authority, handed it down to us. And he wanted to once again quote Abe de Condillac, which describes a good deal of truth. Instead of applying observations to the things we wish to know, we have chosen rather to imagine them, advancing from one ill-founded supposition to another. We have alas, bewildered ourselves amidst a multitude of errors. These errors become prejudices, are of course adopted as principles, and we thus bewilder ourselves more and more. The method to which we conduct our reasoning is absurd. We abuse words which we do not understand and call this the art of reasoning. When matters have been brought this length, when errors have been thus accumulated, there is but one remedy by which order can be restored to the faculty of thinking. This is to forget all that we have learned, to trace back our ideas to their source, to follow the train in which they rise, and, as my Lord Bacon says, to frame the human understanding anew. But after all, the sciences have made progress because philosophers have applied themselves with more attention to observe, and have communicated to their language that precision and accuracy which they have employed in their observations. In correcting their language, they reason better. Thank you for your time. An honor to be here. God, I'm even getting choked up on here. And that's all I have. Thank you.